Hi, in the last session, we talked about tri-state drivers in VHDL and we learned how they work in FPGA design. Now let's talk about VHDL comparators and see how to use comparators in VHDL. Comparators are equally important in digital system designs because you will use them for decision making on different signals and values. So, in this section, we will learn how to use them effectively to enhance the functionality and efficiency of your VHDL designs. You are going to be use them very widely at multiple places, especially in if-else statements and conditional statements. Note that comparators can be used for combinational process blocks as well as for registered process block. Combinational blocks provides immediate output based on the current inputs, while registered process blocks offers synchronized output with clock signals, which provides more stability and timing controls in your designs. We already discussed about that in past, so we are not going deep in this session here. So here is an example of simple combinational process. And combinational output means that the output is generated through the logical gates or lookup tables. They do not involve flip-flops here. So the output will change immediately when your input changes. But of course, transaction delay or gate delay will be applied. Note that I have not written the entity section here as we practiced that many times before. So this is just a architecture section. Anyway, just a quick brief. This module has two signals, signal A and signal B, and one signal T out for output. We will compare signal A and signal B, and if A is greater than B, we will get 1 at the output, else we will get 0 at the output. So this is our VHDL code. Architecture, behave of my design is signal A colon integer semicolon, signal B colon integer, signal D out colon std logic semicolon. Begin P0 process A comma B begin. If A is greater than B, then D out gets the value of 1, else D out gets the value of 0. And if end process and architecture. So first we declare the necessary signals in the declarative section of architecture. Like we have these three signals here, A, B and D out. Signal A and signal B are defined as integer and we will use them to compare their values. And D out is a kind of output signal and it is std logic type and we will get the results in this signal here. Note that we assume that signal A and B are driven by some other part of the VHDL code, means their values are coming internally from some other section of code. But for now, just focus on the comparator. The output of the comparator driving this D out signal, which is std logic type, means D out is indicating the result of comparison between signal A and B, such as greater than, less than, equals to, not equals to, etc. Like in this example, we use greater than symbol. You can use these comparators with your signals, variables, constant, and even with some specific values for your designs. Note that we have written these conditional statements inside the process block, or you can say that inside the combinational process block. So signal A and B are listed in the sensitivity list. Means process will execute when any of these signal are changed. Now, if this condition is true, means if A is greater than B, then D out will be 1. Else, if this condition A is greater than B is false, then D out will be 0. Then and if, and process and end architecture. So this is very simple. Here we have used integer data type for signal A and B, but they can be of any data type like std logic vector, signed vector, unsigned data type, etc. These data type choices are depends on the project requirements and the nature of values which are being compared. Now remember that VHDL is a strongly typed language. Means when you compare something, then both should be follow the same data type. And if it is a kind of vector or array type signal, then their length should be also matched. This is really important to take care because if that is not correct, you will get syntax error for your code. You can also design this system for process block as well. Just define the clock and sync the results with the clock transactions. We already covered this in the register process block section, so we are not going deep today. But try to design the same with your own. If needed, you can revisit the process block section once again. Let me know if you still face any difficulty and we can cover this as well. So that's it for today. I hope now you are familiar with different type of comparators in VHDL and how to use them for any combination circuit or register circuit based on your specific need of your design. In the next session, we will be talking about multiplexers in VHDL. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.